Today we're going to be introing Unit 4, which is about similar shapes. And so first we need to talk about what similarity is, starting with congruency. So congruent figures is what we're going to look at first. Figures are congruent if they are the same size and the same shape. That means that they are exactly the same. The angle measures and the side lengths are exactly the same, but they do not have to be oriented the same way. That just means that they can be turned around. They don't have to be facing the same direction. So we're going to look at these figures and determine if they are congruent or not. Looking at the first picture, we have a triangle or a rectangle that has a length of 9 and 5, and then a square that has a length of 5 and 5. If they were congruent, those would be exactly the same size, which they are not. So no, that is not congruent. When we look at the next, number 2, we have two triangles, and their side lengths are 9, 8, and 6. Then the next one, we have a 9, 8, and 6. It is facing a different direction, but they still have the exact same side lengths, so yes, they are congruent. Number 3, we see a trapezoid that has two bases of 5 and 4. The other one also has bases of 5 and 4 and slant heights of 3 and 3. Since those are all the same size, the same side length, then yes, this is congruent. And on the next one, we've got a parallelogram. That's a 5 by 12 and then a 2 by 12. Those are not the same size, so no, they are not congruent. So that is congruent figures. What we're going to be looking at now are similar figures. In order for figures to be similar, they must be the same shape, the corresponding angle measures must be equal or congruent. Those mean the same thing. And the corresponding side lengths must be proportional. So what we're going to do here is identify what sides are corresponding. Corresponding sides just mean that they are in the same position in both figures. So whenever we look at triangle ABC, we can see that the short side, BC, is corresponding with the short side, FE. And if you have colors, it would be helpful for you to color code these as well. You can borrow some of mine, but please return them. And then we see that we have the long side, AB, matches up with the long side, ED. And finally, the diagonal, or if you're in honors, you know that that's called the hypotenuse. AC corresponds with FD. So then when we go to look at which angles are corresponding, if we look on the first triangle, angle A, that's where we connected our green and purple lines, so then that has to be the same thing on the other triangle. D is what is connected by green and purple, so angle D is equal to angle A. Angle B is connected by green and orange, and so is angle E. Those are also both the right angles. And finally, angle C is connected by orange and purple, and so is angle F. So that means that angle C is corresponding with angle F, and that they are equivalent. So then when we look at our corresponding side lengths, that's when we look at the color coding. So AB, we put in green, and that matched up with DE. BC, we put in orange, and that matched up with EF. And then side length CA was our purple leg, and that matches up with FD. So it helps to begin with if you're able to do those color coding strategies. Moving on to the next page, we're going to look at scale factor. And scale factor is the ratio of corresponding sides in a figure. So when you have two similar figures, one of them is going to be original and one of them is going to be new. To find the scale factor, you just pick a corresponding side on them and then do new over original and simplify. If the figures are similar, then the scale factor is going to be the same for every side length. So we're going to look at these examples to prove that the following figures are similar because they have the same scale factor. So again, we're going to color code here. Let's make the short side green and the long side purple. And it says rectangle GHIJ is enlarged to form rectangle KLMN. So this is our original. Our first ones are original, and the second one is the new. And I want you to go ahead and label those. So what we're going to do to find our scale factor is put new over original. And they have to be on the corresponding sides. So let's start with the green sides. On the new triangle, the green side was 10, and the original green side was 2.5. So that means that we would have to do 10 divided by 2.5. I'm just going to tell you that that would equal 4. And then we do the same thing with the purple sides. Pick the new on top. So the new figure purple side was 20, and the original purple side is 5. And if we do 20 divided by 5, that will equal 4. So our scale factor is 4. We can also tell that that's our scale factor because to go from 5 to 20, you have to multiply by 4. And the same thing would happen. 2.5 times 4 would equal 10. Looking at the next example, again, let's color code. I'm going to make the shortest side green on both of them. And then I'll do the bottom side in purple, the longest side, and then the middle length as orange. And you can do these in whatever color you want, as long as they are corresponding. So when we look at scale factor, we need new and original. So our original triangle is the first one, and then it's creating our new triangle. So to find scale factor, we need to do new over original. And if we start with green, the new green side is 2.5. And the original green side is 5. Well, 2.5 is half of 5, so that's what that would simplify to. If we do the same thing with purple, the new purple side is 3.5, and the original is 7. Well, 3.5 is half of 7, so that also simplifies to half. And then if we do the same thing with orange, the new orange side is 3, and the original orange side is 6, and 3 is half of 6. So all of those ratios are simplifying to 1/2. You could also tell that to go from 6 to 3, you have to divide by 2. And remember, if we're dividing, then we need our answer in a fraction form as 1/2, because we're taking half of that number. So number 8 says, based on questions 6 and 7, what did you notice about the scale factor of an enlargement? What did you notice about the scale factor of a reduction? And what do you think a scale factor of 1 would result in? So number 6 told us that it was enlarged, which means our shape got bigger. What you should notice about enlargements is that the scale factor is greater than 1. It has to be bigger than 1, because you have to multiply a number bigger than 1 to get a bigger shape or a bigger number. Number 7 was a reduction, and our triangle got smaller. In a reduction, the scale factor is going to be less than 1. Like you see, it was 1/2. 1/2 is less than 1. We multiply that by a number less than 1, our numbers are going to go down. If our scale factor was 1, well, multiplying anything by 1 is the same number, so nothing would happen. It would be a congruent figure. All right, looking at the very bottom section, it says trapezoid QRST is similar to trapezoid WXYZ. Determine whether each statement is true or false. So first, let's go ahead and color code these. So we can do our bases first. This short base will be purple, which matches up with Q and Z. And then the long base can be green. And then I'm going to make RQ orange. And how you can tell which side that is based on how it's written in the question. You can see that R, Q are next to each other. And so to figure out what side lengths are corresponding with that, those are the first 2 letters. We can also look at the first 2 letters of the next trapezoid name, which is WX. So those are going to both be green or orange. And then finally we will have ST, which are the last 2, and YZ are the last 2. So those 2 would go together to be corresponding. So now we're going to determine whether each of these statements is true or false. A says angle QRS. So let's look at what angle that is. From Q to R to S would mean this angle. Is congruent to angle ZWX. So I'm going to go from Z to W to X. Well, those 2 angles are not connected by the same colors, so that would be false. Those are not going to be congruent because they're not corresponding. The next statement says we have a proportion, so we're going to look here. We have RS. I'm going to color that green, green, because that line was green. And then XY is green. And then ST was blue. And YZ was blue. So we at least are comparing our corresponding sides. But the next thing you have to check on your proportions is where the original and where the new side lengths go. So let's say that this first one is our original and this is our new. Well, RS is the original. XY is on the new. ST is on the original. And YZ is on the new. So as long as those are the same, O over N and O over N, and you have congruent corresponding sides, as long as your corresponding sides are color-coded correctly and both of the originals are on top and the new is on the bottom, then that is a true statement. And then the next question says angle STQ is congruent to angle YZW. So STQ is right here, and YZW is right here. Those are both connected by blue and purple, so that would be a true statement. They would be congruent. And then we have another proportion set up where we have ST, and that was our blue side. YZ was the blue side. WZ was purple. And QT is purple. So they match up correctly based on corresponding sides, but now we need to check the new and original. ST was on our original trapezoid. YZ is on the new trapezoid. WZ, that was on the new trapezoid, and QT was on the original. Well, we cannot have these two being opposite. If original goes on top on the first ratio, then it has to go on top on the second ratio, and because that's not the case, then this is a false statement. So what y'all are going to do here on this page is write out the corresponding sides and angles and then find the scale factor. I'll do the first one with you, and then you guys are going to practice this. So I'm going to color code. I'll make AB 18 and ED 9. BC will be green and EF will be green, and then the AC and DF will be purple. So our corresponding sides, we just go by what we just color coded them. So AB and DE are corresponding. BC and EF are corresponding. And AC and DF are corresponding. And we just figured that out by color coding their positions. Then if we look at angles, we're going to look at where the colors connect. So blue and purple makes angle A and angle D. So angle A is equal to angle D, because corresponding angles are congruent. angle B is connected by blue and green, and that matches up with angle E. So angle B is equal to angle E. And finally, angle C is purple and green, which matches up with angle F. So angle C equals angle F. Then to do your scale factor, you have to do new over original. And we're just going to read left to right, so the left being the original and the right being the new. And we're going to pick a side. You can pick any side you want. I'll pick 9 and 18. So we've got to pick the new side first, which would be 9 and 18. Remember, those have to be corresponding sides, so that worked because they're both green. And we're going to simplify that. Well, 9 is half of 18, so that simplifies to 1/2. And because that was less than 1, this is a reduction, which means our new shape is smaller than our original shape, which you can see in the picture. So that's what y'all are going to do for the next 2 questions on this page, and then y'all have an exit ticket to do as well on Schoology.